exactly 2 a.m. now. Thank you everyone for being with us. Thank you, Yunwei Chen, for joining. So Yunwei Chen is a professor and executive director of Scientometrics and Evaluation Research Center at the Chengdu Library and Information Center Chinese Academy of Sciences in Chengdu, China. He was a visiting scholar at IU during 2009 February till August. His expertise is in policy-oriented studies of research related to statistics, performance indicators, evaluation, funding, and science policy. He holds a PhD in library and information science from University of Chinese Academy of Science. I'm gonna stop sharing my screen, and Yunwei, floor is yours.
Okay, thank you. Can you hear me now?
Yes, we can hear you well.
Okay, thank you, Marina. It's midnight in America, and thank you for your introduction. Now I can begin my presentation. Today it's my great honor to be invited by Kati's group, and thank you, Marina, introduce me. I will give a brief talk about science maps used for science and technology evaluation. And I came from Chengdu Library and Information Center, Chinese Academy of Sciences. So here I show three logos. On the left is a center founded by me in the Scientometrics and Evaluation Research Center. On the right is a salon for students at the paper potato. Means that we can eat potatoes and then read papers. Means everybody can enjoy the life as a scholar. Okay, in my presentation, I think I can separate into 6 parts. Many of these are some practice of evaluation works in our center. Each work involves some mapping results and how we think about use the maps to carry out evaluation works. In the past, about more than 10 talks, we can find many interesting maps. But how to use these maps and supporting policymakers, scientists, researchers, engineers, or students is a big challenge. I think I have read some papers of Kati, Kevin Boyack. They have a lot discussion about the use of science maps. So we, at the past more than 12 years after I came back from Kati's group as a visiting scholar, I began to do some practice to use science maps as our evaluation works. The first is the performance of research groups, comparative analysis by maps. Actually, these maps just as some comparative analysis results and then showed by maps can easy by readers or policymakers to know the competitions of their own institutions or their researchers. First, let me show a map. This map is not generated by a software or not by some tool, just by hand in Word. And I can make this make a map. What's this map mean? I have listed four groups, all some research centers, one from MIT, one from Oxford, and one from INSEE from Canada. And this is a Chinese group. I want to make a comparative analysis on some group in the field of quantum information. We know we usually in the library and the information science, we will do counting the people's performance usually by the number of papers, citations, H index, or some other indicators. But their list cannot give a whole vision of how the performance of a whole group. I think this is last as a pyramid map that can answer this question. And here the file name, and to the left is the citations per paper. Means if a person got a highly citations per paper, then he can rank at the top. And the brand of the ligand is not the percentage. For example, if there is 9 if there's 10 people, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's nine people. That's the percentage. So we can find this at the MIT QIT. This center have a very broad distribution of people's citation per paper. It has one person at very highly citation per paper. The average citations of his publications is from 91 to 1%, and at the 81 to 90, there's only 1%, and at this region there are 2%. At some other regions, only 1%. We can hear this the word young. Here is very young people about. More than 30 years old, and here some people from more than 40 years, 50 years, and it's about one person, it's more than 80 years. So we can hear that it's very average distribution. But we can hear this group, we can find the difference. There are much the most proper portion of people have relative lower citations per paper. So it's easy to make a compare. We can find that at UC Accuracy, most people have some lower citations. And here, this Oxford's the quantum center, there are most people have the average citation per paper from 21 to 30. So you can have a conclusion that maybe MIT have a best people's structure and a very good group structure. So we just want to use this map to show the difference. But how about the group structure? This map cannot show. So we also do another compare. So this group is from Oxford Quantum Information Quantum Center. This work done about 4 years ago. So at that time, this center have 63 persons. And MIT QIT only have 9%. We can have the different of the collaboration networks. Also, this has generated by Curtis tool. I say Science of Science, ICI2. Yes. And we can hear that the people's 63 people have collaboration networks. But these 9 people, we can have a difference. The collaboration between among the 9 people in the center is not too strong. Yes, it's a very interesting thing. But this group have very some strong researchers have very important results in the field of the quantum information. For example, the Peter Shaw have an algorithm of Shaw algorithm, very key method for the field of quantum information. Actually, we can show the different, but we cannot conclude which collaboration factor is better. We just want to show the difference. And the right, this map, the people maybe do some theory research more. And the left, there's a theory and some use application research all have, and they have, we can handle fields, some materials, physics, chemistry. So as we use the map to show the different research groups. Okay, this is just the Peter Shaw I have talked about. And use this map, we can how the Peter Shaw's contribution to the field for information, quantum information science. This is this paper just is a very key algorithm of Shaw algorithm. Then you can hear himself also do the related works until these years. And he also have some other publications, but not as the key contribution to this field. This is a key contribution, and this group are other works of himself. This is the function of science map to help us to understand this field, quantum information field, who contribution and how he or she contribution to the field. Yes. Another way we can show I just talk about this map. We cannot show which map is better. Also, we have in recent years we have do a lot of collaboration or citation networks. For example, these two works of collaboration networks. If you compare, you cannot answer which network better, which group have a better performance. So we have to use some method to answer this question, which have a close collaboration, which network have a condensed density. Also for this from this network, we still cannot spot the difference between the two pictures. So we have to do some computing works. This just we can. So as a result, we want to compare the different network by counting some indicators of the network. For example, the ratio of isolates, the ratio of clusters, or the ratio of nodes in the largest cluster. This work have done of just I came back with, from Curtis group after about 4 years later. We all know, and I have a background of life science, so I have do a lot of review works about the field of life science, and we found and asked some experts to conclude that in the past 50 to 100 years in the field of life science, we can find some very important technologies. For example, the recombinant DNA and monoclonal antibody technology is very important contribution to the huge progress in the field of life science. And there are all those, so we call the such kind of technology means impelling technologies. There are also some other technology, for example, formation technology. It's very popular for everybody. You eat bread, you eat bread. That is the basic technology, that is fermentation technology. It's also important. There's also ELISA diagnosis technology, but this is technology just popular for very short years. So so these two important technology even is very even it cannot be like for the human life, but the function or the contribution to the progress of life science is not stronger, it's lower stronger than the former impelling technologies. So but if we have do the collaboration networks of the patent underneath, we cannot find any difference. But you can understand that in the networks there are more than millions nodes in the network. It's very hard to have a separate find the difference. So we calculate the two groups. We can find these two groups is this in the upper ones is non-impelling technologies of the green one is fermentation technology, and the pink one, the purple one is ELISA technology. So in this two non-impelling technologies, the ratio of athletes is higher. And at the two impelling technology is important, a huge contribution to the life science. The ratio of athletes is lower. The network is always patent underneath. We can understand is universities or institutions collaboration network. And as the clusters, cluster also so the cluster ratio, the impelling technology also lower, but we have to show that to tell you that one athlete also calculated as a cluster. So it means there's in the collaboration network of non-impelling technologies, the athletes is more. It means that the collaboration behavior is few than the impelling technology. So we can when we watch at the ratio of nodes in the largest cluster, we can find is in the two impelling technologies after years of development, the ratio vary the most of the patent underneath in the field of impelling technologies, recombinant DNA and monoclonal antibody. The most of the institutes or universities institutions have direct collaborations or the indirect collaborations and merged become a very big cluster. It means there's a collaboration behavior is very popular. Okay, this just want to show the so why how if we compare these two kinds of technology, just we can know and these two kinds are impelling technology and these two are non-impelling technologies. But how if there's usage, how to use? So we can we have another. This is also the average degree and the diameter. We just also the same. The two impelling technologies are the average degree is very higher. So when we now add a very new technology, I mean synthetic biology. This is very new very new new field in the past 10 to 50 years. So we just wonder whether could synthetic biology technology could become impelling technology in the field, or still is also non-impelling technology. So we can also calculate the patent underneath collaboration network. We can find if the position within the region of clusters, synthetic biology close to the non-impelling technologies. Okay, they all very close to this in the formats is close to the two non-impelling technologies. But we have to think one thing, that this is very new field. Maybe it's still at the first stage of the technology progress. So we have to think about, if this is still at we compare to their four technology at the early stage, then if we normalization of these five stages as the all at the beginning stage, maybe synthetic biology just at half of the performance is close to impelling technologies, and half of close to non-impelling technologies. So we cannot conclude whether could this new technology can become impelling or non-impelling, but we can maybe we can do at a few years later can do start work again to find whether it's close to impelling technology. Okay, this is so the third work I want to show mapping weighted citation networks. The purpose is to now there's a lot of community detection algorithms, and the usage of the community detection method have been used widely, and even some very huge network often include about more than millions and the 10,000 nodes. We can, at the computing method, we can know the difference, but actually we can very hard to see which see the different community structures, the different which nodes merged from this community to another community. So in order to show the different algorithms, we just do a comparison of weighted citation networks to the original citation networks, just to show use this mapping method to show the move of some key nodes from one group to another group. So the tools is SCI2 and TDA. Database is Web of Science. The data is used the 4,470 publications published in the Journal of Scientific Methods from until 2016. This is the method. We original network is very easy to understand. Then we use the TEF IDF method to give some weight to the links of the network. Okay, this is how to compute. It's easy to understand. And the IDF, we have to calculate the precision in keywords, title, or abstract. We just defined how to give a different weight. Okay, then we just want to show the result. Okay, at the left side is unweighted network of the. This is not the whole network, just the biggest cluster. Also, we can also name the main component. So, and when we use the TEF IDF to get the weighted network, we can find some at this 4 nodes moved to mode. This we can have this node moved from the red group to the purple group, and there are 4 nodes. Whether this is very micro view of the different groups move under the same the different methods. So it's very helpful for us to understand how we can use the different methods to supporting our case studies. The nodes, we can the nodes 46. The title is Knowledge Network Centrality, Formal Rank and Research Performance, Evidence from the interaction effects. Then in unweighted community from group 3 means research evaluation. But actually, when we read the whole the full paper of the paper, is much likely to a collaboration research, and the performance just as not a main result. So after we read carefully about the 4 publications, we can find that the 4 nodes all move with the direction of better appreciated of community assassination through our weighted methods. So this is very good encourage us to use our weighted method, have a good performance of the unweighted method to have the network analysis. Okay, this is the third. Then the 4th work of us is mapping global patent distribution. Yes. Now we have go to the area of big data area. So especially the papers and patents were huge number. For policymakers, it's very hard for them to calculate the change and the precision of the ranking of patents. So in our group, we have collected all the patents in the more than 100 countries in the world, and we make a website of the global patent, and we can, and at the it's like a dashboard. We can, the policy makers can have a look at only this one map can know which country ranked first, and where is the newly patents origin from where, and we can have the verb improve the progress. We can also have the subfield distribution. Actually, we can also find the technology patent rights transfer from one country to another country, or the inter-transfer for the patent rights. It's very interesting. Actually, this is just the map. Actually, we have also have in the website, you can click your mouse to enter each map to watch the details. I think it's very useful for policymakers to understand or to know the whole structure, the whole features of the global patents, whole field, or some subfield for life science and information science, materials, or some others you can keep. And for each country, you can click here to go to the American, Canada, China, Japan. Also, you can find the patent information. It's very useful. It's very, if you can find, we can all all do such things. Actually, some of company, research institutions have asked my group to make some particular patent dashboard for service for themselves. This is the work of for this is mapping. That's very useful mapping. Yes. And the fifth I want to also is very interesting. Let's look at the quantitative data objectively. This, if we can also as the rankings and the numbers, we can find as the number of highly cited researchers. We can, oh yeah, China ranked very high, and until to 2018 ranked 3. But actually, we want to use a map to show the accuracy factor. We can find that there's the China, even in materials, engineering, and chemistry that much more highly cited researchers. Actually, at the UK, Germany have very average distribution. So I think that if we watch to the 22 fields, we can, it's very much more information, better than use this just as the list of numbers. So this we can show the a very simple map, but can give us a very deep watch of the accurate information of the highly cited researchers distribution. Yes. Okay. So in the past 5 part, I introduced some how we use the mapping method or science map to support our policy researchers or evaluation works. Most are watch the help up to understand the information behind the data. Also, all the works are carried out by this group. This group, MERSERC, means Scientometrics and Evaluation Research Center from Chengdu Library of the Chinese Academy of Sciences, located in Chengdu. This is established in 2019. Yes, and here this is me and some other scholars. So the purpose is to just to this very have to thanks to Kati Bonner and Kati's group in 2009 as a visiting scholar at there, and I effect and have learned much more from her group to also from that time I want to do some works in the field of scientometrics and evaluation. Then I came back, I established this center just to do some quantitative analysis of science technology development and research on some interesting topics of science. And it's a very open research center. We also host visiting scholars from all over the world. This is the work of this our group, scientific research and net, and we have published papers, books, reports, translations, and we also hold a very famous conference. Means the name is Chengdu Conference on Scientometry and Evaluation. Yearly, we Kati knows this conference. Maybe next year we also want to invite all the researchers from the global researchers to this conference and give important talk. So we have to actually these some mapping works, many of them carried out and lead by me. So actually I start my mapping road from IU with Kati's group, and this is this is a picture from IU Bloomington from August 6, 2009. Here's Kati. Yeah, this 12 years ago. Anybody here is still in Kati's group? I do not know. Okay. So I have to, so at that time, I know mapping is very, very interesting. And I have at Curtis, as a visiting scholar at Curtis Bloom, I half year, I have participated with many activities, some talks and some conference, and some as also the science map exhibition. I have also translated many of the introduction of the science map into from English to Chinese, especially with Hanying, this with Dalian Technology University in China. We have translated some into Chinese. So we have to use map. It's very interesting work. We have to talk some thinkings about me to you. This picture is drawing by my doctor last week. It's actually we can show. Sometimes she will look at my mapping the jobs, and he usually carry about if at the center, at the network center, the biggest node, she will pay much attention to the biggest nodes. I will talk to her. This is the biggest node in the center. It's just a person in the center of the research field in the whole world. Yeah, so today she told me in the morning she have watched some talks of especially the piano 1 hour for piano teachers, and she are very exciting, and the piano can play very good. And she likes drawing about, I think maybe effect by me every day, every year. I have finished some mapping jobs in my computer. I will also show to her. So this time she want to draw a traditional Chinese woman. I ask her why she will put her ears very far away from the head of from the woman. She said that she starts to want to highlight the rings about this woman. She thinks the rings is very important. And also why the eyes are very big. She wants it. She said it's not actually nobody's eyes can very huge in a face. Just she know big eyes can make the eyes very important in the face. So she want to make it very big, and so want to show to us that this beauty's eyes is very important, and the rings is also important. So just her contribution to this. So this tell me that the same maps, maybe we can got different information. Yes, she want to draw these pictures mainly want to show the eyes and the ear and the rings. But for maybe for different readers, different audience may got different. Maybe somebody maybe found, wow, yeah, this is the woman's mouth is very beautiful. Maybe when we found the fingers is very nice. So this talk indicates that only the same map we can talk to audience, to readers. Maybe you can give different results. So we have to explain a map very carefully. Maybe you think this Max want to tell the information A, maybe other audience get the information B, maybe sometimes very understand in different way, right? Okay, so the conference of our this is from 2017, 2018, 2019. And this year's online conference is finished. The next year, the Chengdu conference on scientometrics and evaluation will hold on September 2022. Also in Chengdu. This big. This just Chengdu city. The Cirque, our center is located here. Yes. This you can very beautiful. It is a snow mountain. Snow mountain. Yes, Chengdu city is the only city, biggest city in China. You can find the mountains as in the center of the city. It's very very beautiful. So we welcome all the friends and today's audience and the host experts to welcome to visit our center. Also, you can visit and give a talk or have as a visiting scholar and work and study in our center for months, half years or years. All is okay. If you feel free to contact me. Yes, Chengdu also a very beautiful city of a panda city in China. You can. It's very easy to find many pandas in downtown, and there are some zoos and some research centers that only focus on the panda. So well, welcome to our here. I also not finished here. I also have a involving network to show to us. Just a moment here. Okay. This map is a collaboration network. Is just as the ideas from Curtis. There's a group collaboration network. It's very collaborative, famous work has been cited by the Journal of Nature. We also want to count from the. You understand that in 1985. The patent law of China have established. So at that from that time, the Chinese Academy of Sciences, some institute began to patent applications. But how about the collaboration among the more than 100 institutions from among Chinese community sciences? So we make this network, involving network. We kind of year by year, the collaboration network between different institutions increased yearly by yearly. Yeah, especially in the 22nd century, the collaboration among us become very close. We can find, yes, is increased yearly by yearly. Yeah, we only calculate to 2009, maybe 2009. Okay, just I came back from Curtis group. Maybe the past 12 years, the collaboration become much more close and have a density increase much more. Yes, we have. Yes, it's very interesting to show the information. At from a few seconds, you can understand how the 20 about more than 25 years program of the collaboration networks counted by patents. Okay, Medina, this is my today's pronunciation, and thank you again for Kati and Medina, also for the audience. Thank you.
Thank you, Yunwei Chen, for great presentation. Thank you very much. We still have 15 minutes. please, if you have any questions, attendees, you can post it in the chat. Otherwise, we have it in 1 hour and 15 minutes, another presentation by Soren Oyer and Salomon Kabongo. In the meantime, we will have maps and macroscope demos for you. So please enjoy. Thank you again, Yunwei Chen. Thank you.
Thank you. Thank you, Marina.
Mm-hmm.
Hello, can I have one question?
Sure.
Sure.
Okay. This is Asako from Japan, and thank you very much for your great work. And I would like to ask you, how is the situation in China regarding the use of the evidence that you presented in actual policy making? Because in Japan, it's now we are trying to change the policy making into evidence-based policy making, and the policymakers are learning to use the evidence, but sometimes it's very hard for them to understand the numbers, and I mean the meanings of from the science networks or like citation matrix or something like that you are presenting. So what is the situation of the data literacy of the Chinese policy makers, like in a government are really using these evidence in policy making, or what is the situation?
Okay, thank you, Otto. Thank you again, and your good question. Yes, this is just actually we have do a lot of analysis at basing the quantitative analysis or just at evidence analysis, but actually. We think that our result is very interesting and have the strong suggestions to the policymaker. But most times of they think the result of your finish just to show the truth. Show the truth, but they have more willingness to we can show them why, and the back information of the data and the results. Why have this phenomenon? Why is the result is this result, not other result? So, but this actually is very hard to understand. So sometimes they think the result of our evidence if the evidence can supporting the policy making, we have to do further details analysis, deep analysis. I think that we have the same situation. Yes.
Thank you very much. Thank
okay.
you.
Thank you. Thank you.
Thank you, Asako, for question. If anybody else has a question, please post it in the chat or feel free to unmute yourself.
Yeah, if no question, I also want to show a picture. It's very interesting. Yeah, here is a picture, right? Maybe we can see there's a girl flying. There's a girl flying to the sky. But this is drawing by my doctor. I asked, what's is a tree or heaven? Yes, This is a question. I think is imagine of her to show the girl fly to the heaven, and the heaven have a heart and very huge, and the heaven also have root on our earth. But I understand it. But at her mind, this is just a tree, just a small tree, and there's a girl just fly around the tree. So I just want to maybe we finish a map. She want to explain information, but the readers can got can understand a very different way. So just as I talk in my presentation, we have to how to explain the map is very important. It's have a limitation of our idea. Maybe in Chinese we can talk. This is a girl, Miss Chang'e, who lives in the moon. But maybe it's for medical or Oscar, maybe it's very hard, maybe hard to understand who is Chang'e. But maybe for everybody in China, he know Chang'e is a lady lived in the moon, right? Okay, thank you.